welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice. I'm host of House of ZK Radio and also education lead at zkVM. Today I'm joined here with co-host Pavel from House of ZK and our guest Maxim, a compiler engineer at Noir. So thank you so much for being here today, Maxim. We're very excited to have you and to dive all into Aztec and Noir.
Yeah, thank you for having me.
Yeah, thank you. Wondering first if we can start off with an intro about yourself. So how did you get into the Web3 and ZK spaces and focus specifically in the Aztec ecosystem?
Yeah, so I've actually been at Aztec for almost 3 years now. I've been working on Noir the whole time. Before that, I was doing a master's focused on ZKP acceleration. And preceding the master's, I just was a normal kind of computer science student who was first diving into blockchain, and then I just became obsessed with ZK once I couldn't understand it. And here we are, still trying to figure it out.
Yeah, I think we're all on this journey to try to figure it out together, and it's really great to hear that you first kind of took that academic route and first got introduced through ZK when you were studying computer science, and then joined Noir afters. When we have guests, hear guests from all different kinds of backgrounds, so really great to hear that from you. I'm wondering if we can go into some more details about where Noir started, at least when you first joined. So I was wondering if you could speak about some of the main intentions that Aztec had in creating its own ZK DSL and how Noir compares to some of the other existing ZK DSLs that may focus on privacy, like, for example, Leo, and then there's some other DSLs out there that are Rust-inspired, like Cairo. So I was wondering if maybe you could walk us through some of the intentions that Aztec had in creating its own DSL.
Yeah, so Noir actually started outside of Aztec. I was first born out of Kevandre. If you know him, he wanted something that it was easier to write circuits, but because at the time it was either libsnark, like C++ libraries, or circom was, I think, kind of just started to come onto the scene, but there wasn't really anything that was programming how we normally know how to program. And that was the first motivation, just something that was easy to program with. And at the same time that he had started to initially work on it was when there had been the initial explosion of proving systems. I can't remember exactly what it was at the time, but it was all within the same few months. You had 3 or 4 new proving systems. Plonk had come onto the scene, and there was other variations. And it wasn't just we're just going to use Groth 16 now. It was now it's obvious that if you have any kind of language that you want it to have long-term maintainability, you're going to need some kind of IR or intermediate representation. So then that was one of the other really large design choices for Noir. So Noir compiles down to, before compiling to a crypto backend that is actually going to generate a proof, it compiles down to a SEER, the abstract circuit intermediate representation. And so that was another large design choice for Noir. We wanted it to be backend-agnostic and easily extensible for new crypto backends.
Got it. And also wanted to hear some more of your thoughts in just the general ZK DSL landscape. So we've been seeing, as you mentioned, kind of Noir's intention was to have something that was easy for developers to program with. And I feel like we've been seeing kind of a lot of those trends with just abstracting all of the complexity of ZK, especially for developers, and having them focus on, building the application as opposed to knowing all of the underlying cryptographic details behind ZK. So there's kind of a trend in adding these abstraction layers on top. So we've seen originally from handwriting circuits to teams like Noir building zk DSLs to even zkVM development. So I'm curious to hear just about your thoughts on the advantages that these zk DSLs have in this kind of abstraction layer stack compared to some of the other kinds of tools that are available, like with, say, handwriting those circuits directly, or with zkVMs that are currently existing in the market, and if there are any kinds of trade-offs that you see, say, in having this simplicity compared to having it be very efficient.
Yeah, so I mean, trade-offs everywhere for sure, and it's kind of every in this scenario, similar to like, just choosing what programming language to work on for a regular, not ZK project, different languages or different tools, and depending on what you want to build, you might desire a lower level of or like basically no abstraction, or higher level of abstraction. But to like get to a little bit more specifics, I think Noir, one of its other like main goals of developer experience is that it does bring a certain level of safety when you as a developer have to stop it's just, you don't have to kind of be coding like you're on a minefield or something where everything you do might possibly lead to a critical bug that's been abstracted away for you. It's handled by the compiler, and like, of course, the compiler can have a bug too, but it's self-contained. It's usually, you have more eyes on it, on the compiler, versus on like a single application that you might be working on. Similar thought process also with, Rust wanted to add memory safety to C++. So, okay, we're gonna lean on this. We're gonna put this into the language. That, of course, has challenges though, and complications. And specifically with Noir, like a very basic example is we support if statements, which is something that like every programmer who works is like, yeah, of course we support if statements. But for a ZK developer, if statements aren't necessarily like a true concept on their own thing. You have to basically mock what an if statement would do in a ZK circuit, and that's what a circom developer is required to do, or someone who is handwriting their circuits. So Noir, now you can just program as you would normally, but once there's some hidden performance costs there too. If I want to do something like, let's say I'm performing like a hash, but I decide to do it in the if and the else block of my if statement. In like normal programming, you think, oh, okay, it's only going to execute if like my if is true or if it's like false. But in a ZK circuit, you execute basically both branches of the if. So if I can take out that like very expensive computation and move it before the if statement, I can avoid like doing it twice. So these like nuances still come in to play in the DSL, although it is like much more high level, so it's easy to kind of step on your toes. But this only becomes like more pervasive as you get like higher and higher level abstractions. And then sometimes there's going to be costs that you simply can't get rid of. zkVMs are going to always have an overhead, like fundamental overhead, because they're not just proving that computation that you desire. They're not just proving, let's say, x plus y equals z. They have all the other overhead of, accurately proving a RISC-V trace. It's not just this, not just that computation versus us just saying a single arithmetic gate. Oh, this is the proof that I did this correctly, or that I know these values. So as you go up the abstraction layer, it just becomes so much harder to catch these foot guns, these pitfalls. But I do think it makes things safer generally to not have not relying on every app to basically be programming in a safe manner or programming basically a safe manner. Now you can rely on the compiler or the tool and have it be universal and standard. That's, I think, one of the largest kind of differences you see as you go up the stack. But so Noir, we've tried to and we've realized it over time as people have been like working with Noir. It's like provide like a reasonable default and like a reasonable way for people to get started, and they don't need to like know that much. But if they do want to like get deeper, if they do want to like hand optimize or maybe treat it like a low level like circuit language, they can start to do that. And that's, I think, a good way to like intro developers too. You don't scare them right away. And then if they want to get into the weeds, they can, which is not really possible as much on the zkVM because you're entirely at the will of the VM and the compiler, the zkVM compiler developers. Um, but versus in Noir, we try and, provide the abstraction. You can go low level if you want.
I guess a continuation on that. What is the goal of going low level? I know like in like the EVM you can go into the let's say like assembly level for like optimization, gas efficiency. Would it be
Mhm.
in a similar direction in terms of efficiency?
Yeah, it's performance, performance, performance. It's always performance. Usually, I don't know any other time reason, but the like another kind of very common optimization in ZK circuits is just being able to not is the unconstrained execution, where essentially you stop proof. You're basically instead you have inputs to your program, but now maybe partway through your program I now want to do something else, but not in my circuit. And then I can inject extra information in the middle of my circuit, in the middle of that execution. Because that's a very powerful tool. And because it's very, and like because we're just proving we did something correctly, we don't necessarily have to compute it directly. So like the simple case is the example of division. Division is quite expensive in a ZK circuit. So instead of just like performing that division in the circuit, I'm going to jump out of the circuit, perform the division there, and then in the circuit, I'm just going to check that I performed the division correctly with a multiplication, because multiplications are cheaper. That's like the most basic kind of example of something you might do to optimize your circuit. But as you start to do these things, it does start to lead to, safety concerns again. What if I didn't check the division after? Then a prover can trick someone that they did compute something correctly. So that's where, it's that kind of trade-off again, I guess. How much performance do you want? What safety costs are you willing to, or safety risks are you willing to take on? Are you confident in the kind of checks that you've added? Same thing, like for Solidity assembly. It's a lot easier to make a mistake, mess something up, you pad a zero the wrong way, and then, it's exploited. The contract is exploited. So similar is actually very similar, just rather than gas and assembly optimization, it's constraint count optimization.
Got it. So within this kind of whole stack, there are some trade-offs. Say with moving up the stack, there's more overhead, like what you mentioned with say zkVMs perhaps having some memory overhead, but at the same time, moving down the stack, if you're trying to optimize your circuit to optimize certain operations, then there may be some more doors that are open for safety concerns. Yeah, really great that you mentioned kind of the trade-off plane that developers need to think about when they're navigating through this.
One more thing to note though is that like ZK DSLs can definitely be extremely high level, I think, as evidenced by Noir. And then other DSLs that exist nowadays are also quite high level, inspired by Rust or Python. So the I guess it's a lot easier to be customizable with the DSL because it is the domain specific language. So we can provide for you, traits, closures, very high level programming concepts that are part of, normal high level programming languages, but it doesn't necessarily come at, a fundamental overhead.
Got it. And just on that topic of customizability, you mentioned that Noir was designed to be more backend agnostic. And for a Noir program, it compiles to some kind of adaptable intermediate language. And then from there, it's compiled to some kind of proving backend. And from my understanding, Noir is compatible with quite a few. So there's Aztec's proving backend, some other Plonk-based backends, or even ones like, for example, Marlin. So very curious to hear about in providing this kind of customizability to developers, providing them with different kinds of choices of these proving backends, how that affects their overall developer experience, and if there are any kinds of scenarios you see where a developer should say, choose one proving backend over the other.
Yeah, so I largely think as just like a pure, like you're writing a Noir app for the first time, like that's the whole, I guess, goal of being backend agnostic. It should not affect your developer experience at all. You should be working purely with Nargo, Noir's package manager, and just kind of, coding as you would for any other Noir, any other program. So it's what's really nice about having this kind of extensibility. And I guess to the point of when you might actually choose to have a different proving backend, that's really dependent on your use case. The most common kind of case in the crypto world where people might like switch backends is, okay, I want a really cheap verifier. I want a Groth16 verifier on chain that's like really cheap gas, really small proof. And that's the final thing I'm going to submit on chain rather than a massive Stark proof that might be like megabytes in size. So it's not really, depending on the program, it might be succinct, but it's not succinct enough for how much it costs to verify that. So that's the most common example, but generally proving backends trade off on, it's either proving cost, verifier cost, and proof size. So among that, what combination is ideal for your use case is usually what's going to affect like what you want to use. So in the case of Aztec, we want small client-side proofs that are resource constrained. So we're maybe okay with eating like a little bit more verifier costs so that we have lower proving costs, lower memory consumption. But there was other projects that recently started building their own backends for their own purposes. Was like WorldChain did. They're building like a Spartan backend using Word because they had their own separate needs. And then there was Pluto was working on a folding backend for their own separate needs because they needed things more on the client side, but they still wanted like a nice front end to be able to program in. So that's like, it's largely based off, what your application like needs. But a little caveat to that is that, once you start to get into backend specific things and you really try to optimize, that's when Noir might start to look less like a, general language that supports everything. You can start to maybe make some optimizations that are like specifically useful for a backend or for the specific arithmetization. But generally, if you're just like want to start prototyping, want to start working, you're never going to like have any kind of backend specific things injected into your Noir program.
Got it. And it's really great that you're kind of providing these end users with the opportunity to, choose which backend is most appropriate for the application they're building, like what you mentioned, looking at the different kind of trade-offs, say, between the proving costs, the verifier costs, proof size. So it's really great that all of those options are presented to those end users. Also very curious to hear more about the whole life cycle for a proof being generated with a program, and if you could walk us through that. So like, for example, if once the developer writes the program in Noir, you mentioned that it's then compiled to an intermediate language, and then it's then compiled to the proof backend. But wondering if you can just dive into some of the more details involved in that process, and then if there are any sorts of maybe specific challenges, which I know we previously talked about within that compilation process, but just wanted to hear some more about that process as a whole.
Yeah, so kind of as I mentioned in the previous question, like you can get started without, thinking about a crypto backend at all. You can just, go to Noir, download Nargo, and get started just like coding your Noir program. You can compile it. You can then, execute it. You might have also heard of execution referred to as witness generation. That's just, we refer to it as execution in the Noir world. So all Noir is going to first do is like, okay, let's say you make your little program that all it proves is I know like the value of z for like, or like I know the value of y for like x plus y equals z. So you're going to compile that program. It's going to compile into like a very small, just a seer, and then you can run nargo execute, which will just execute and generate what we call the partial witness. But you can just think of it as the witness. And this is what you're actually going to send to the backend. So you'll have your seer program and this witness that nargo executed for you. And now you're actually done. You're like out of the Noir world, and take your proving backend of your choice. So I'll use Aztec's Brettenberg as an example. You'll call BB, and you'll pass it that proof, or sorry, that seer circuit and that witness that you generated, and it's going to generate a proof for you. And then when I called it earlier partial witness, the reason I did that is because Noir's a seer. It's very limited. It's basically a bunch of arithmetic expressions and a couple extra like opcodes to handle memory operations and like special, very expensive operations that we refer to as black box functions. Generally, these are just custom gates in the backend. So just like very specialized, expensive computation that we want to optimize. So like an example of this is that the like Poseidon 2, like the hash permutation has a black box function which we call as part of our Poseidon hash function. So that's gonna further generate some witnesses on the backend side. So that's why we call it like a partial witness. But in the Noir world, like that witness is the final witness, and you can check your execution is valid or invalid based off that. But the proving backend is going to do a little extra work. And then once it generates a proof with that proving backend, you can then check verification. If you were to be building an app like that is actually, on chain and integrated with like a smart contract platform, you would generate your Solidity contract, and that would have a Solidity verifier that would then you could just send your proof to that, and then on chain it would verify. I now verified this zero knowledge proof, and based off that information, you can do smart contract interactions, perform different autonomous actions based off that proof. And actually, there was a team. So we used to only support Solidity on Brettenberg, but a team called Garaga that's in the Starknet ecosystem, they recently built a Cairo-based verifier, so you can actually verify Noir proofs on Starknet as well now, which is like a very exciting development, something we've been wanting for a while. So it's like not only now, backend-agnostic, but once you have a backend, you can now make it almost, chain agnostic, just need a new verifier.
Nice. So the program basically compiles to a seer circuit, and then that partial witness is also generated. And from there, depending on the proving backend that the end developer is using, from there it'll generate the proof, and then they can go on to the verification process, which you mentioned, like either, say, for example, Solidity contract or like a Cairo-based verifier, which you guys have recently newly developed. So that seems like a very kind of like streamlined process for the developer.
Yeah, and I definitely think like as a developer, you don't need to be thinking about this crypto backend, at least until you need to. Like it's not, you can just start like working on the command line as you would expect to be working with other CLI tools like Cargo. Obviously, Nargo is also Rust inspired like the rest of Noir, but yeah, you can start to validate whether or not your program is works without having to worry about even proving or verifying yet. And of course, you can also do this execution in the browser as well, because same thing with needing to prove client side in order to have kind of privacy. You need to also, do the execution there as well. You can't be sending your private data off to a server to do the execution.
Right. And just some more details about kind of the features within Noir. I'm wondering if you can speak some more about some of the implications for, I know that Noir really emphasizes making the private state kind of the first class default primitive that's enabled on Noir. And also very curious to hear some of the nuances between the private state as well as private inputs that developers may include within their program logic. So maybe some nuances between those differences and also some implications with making just that private state, focusing on privacy as a main priority.
Yeah, it's a great question. So I'll say, yeah, private state, because state is usually, something that we think of as being like persistent. When I'm proving my Noir program, I just have like, okay, I'm just telling you I know some private value. I don't necessarily, but now how do I like maintain that private value over time? Like the most basic example is like, let's say I want to do a private transfer. And as part of that private transfer, in order to like uniquely identify myself, I generate some note that is like associated with my private key. That private key might be inputs into the program, but it's not like state in the program because it's not stored anywhere. I'm just using it as the state is actually stored outside of the circuit. The private input is just what I'm feeding into the circuit to show that I know what I am claiming to know. And actually maintaining that state is a large problem in itself. It's like just for like zk app developers. So now let's say I have, in the example I gave like just one private transfer example, but usually this is going to be, living in some kind of smart contract where you have, a tree of all these different potential nodes. And if you as a user, let's say, have deposited 10 different times into this contract, let's say with 1 ETH each time. Now I have 10 notes that only I should know, because if I give them to someone, they could withdraw my money. So how do I now maintain this state and actually, interact with it and use it later and continue to use it? So that's where the challenge like really starts to come in, but that's like more of a, actually like just general, once you start to become practical and apply this to like a real ZK app, you have to start thinking about. So Noir, like private inputs are first-class citizen in Noir because it's like what ultimately is Noir's value add. We very much need, like we want you to have this private element, but you as a app developer need to kind of actually have some almost like just infrastructure surrounding your app to be careful as well. Basically the circuit proving this private inputs is just like not enough to guarantee privacy. And that's largely kind of where Aztec tries to come in. So we basically built this execution environment for private state and also for public state to interact with your private state in an easy way. So that's where kind of the motivation for Aztec comes, because once you actually want to try and build a ZK app, it starts to become, you spend more time on your infrastructure than on your ZK circuit. You might write your ZK circuit actually in like, very quickly. And then the rest of your time is spent doing normal app development. There was a team I had spoke to a while ago called Sysmo. They had shut down I think like not too long ago, but when I had spoken to them, they said they had built their like Circom circuits at the time, like very quickly. It was like the beginning of their project. And then everything that they spent their time on was basically the infrastructure surrounding their like ZK app. And that's basically them trying to maintain private state for all their users. And that's where the challenge like really started to come in.
Got it. So it's not just, optimizing for the ZK circuit itself that these end app developers need to consider, but instead also about that kind of surrounding infrastructure environment.
Yeah, and so like the thought process is that, Noir is, you can do whatever you want with it and maybe build your own kind of state management or execution environment. But we hope that, something like Aztec, and we believe it will be basically the best place to deploy your Noir app. It'll be the easiest place because all this, private state, this execution environment you would have otherwise had to build has been, it already exists.
Got it. And also wanted to talk a little bit more about just general security on Noir. And I know we previously talked about how there's this trade-off plane in optimizing, say, certain operations and optimizing for performance. There is that trade-off where there's some more safety considerations to be aware of. But wondering if there are any kinds of, what you see, common circuit vulnerabilities that developers should take some precaution on, or if there's any sort of general strategies to mitigating these kinds of vulnerabilities. And I know that that Noir has the capabilities for these under-constrained circuits. So I was wondering if you could talk a bit about some of those implications there in terms of how they optimize for performance, but then also some of the other kinds of security considerations that need to be considered as well.
So yeah, under constrained circuits are probably like the most common bug that we see, and usually, the thought process with Noir is that, if you're not using the unconstrained functionality, the compiler itself should not be under constrained, and you can rest assured everything will be okay, and it's all safe. But yeah, the moment you start to actually use unconstrained Noir, which is just Noir executed as a normal programming language, you need to make sure that you accurately constrain it once whatever inputs you bring back in. And this is also another common bug that we see is not accurately constraining perhaps your inputs or your outputs. So you say, oh, I received some inputs into my program, but if they were not appropriately constrained, someone could still feed garbage into there and potentially trick the verifier. So you need to appropriately constrain whatever inputs you have that are coming basically outside of the circuit. It's still kind of that same idea. So whatever's not already within the circuit needs to be appropriately constrained. And I think it's going to be a very common thing. Like this is probably going to be the most common bug we see in zk apps like over time is from these unconstrained functions. There definitely will be like efforts to try and improve safety surrounding this or automatic input validation, but there's always, once you start to make like ad hoc things, you as a developer have to be very careful about what you're writing, because it starts to become, you're doing something novel. There isn't something already out there to validate what you're writing. That's probably the most common safety concern. Otherwise, it would just be, not appropriately recognizing sometimes how zk circuits like actually are supposed to operate, because you're proving something. You're not necessarily just just trying to execute it. So if you don't appropriately lay down your constraints, once again, it can lead to issues where the prover might actually be able to trick the verifier.
Got it. And then also just on the topic of strategies and ways that developers can go about with this, are there any sort of strategies for developers to, say, optimize their circuits further? I know that we previously talked about kind of the idea of optimizing for lower gas usage is kind of analogous to reducing or optimizing for lower number of constraints that are being used in these programs. But curious to hear if there are any other sorts of general strategies that devs can take, and if there are any sort of caveats that are involved in this process, like with, say, some safety concerns.
Yeah, so I'll expand on kind of the concept I brought up earlier with the unconstrained functions. I gave an example of just, a simple division, which is actually no, the Noir compiler already does that one automatically because it's just so common and so used. So that's not one you're going to have to like write yourself as a developer. But a common one that I see developers making the mistake of is, let's say you have like just an array that you want to write into under some conditions, and maybe you want to do it a lot. Maybe it's like you have a lot of inputs. It's like in a loop, and you're writing into this array. Well, as we mentioned earlier, in a zk circuit, you have to execute both branches and of an if statement, and you're also potentially doing a very expensive write. How could we, replace that with a read? Is something that I think is like a very easy win that most developers could do. So instead of doing the, whatever your write operation that you wanted to do over your array is, do that in unconstrained. Go back to constrained, and then just read from the array and validate that the inputs are what you expect versus writing in constrained. So that's a very common thing that I see new developers like making the mistake of, but it's also an optimization. So I understand. And if you're prototyping, you're not going to be worrying about maybe these like little optimizations, but that's just like a very common one. And that's actually something, we do for some of our SHA-256 hash function does this because it would be very expensive to actually, reads are less expensive than writes. And then once you start to add these conditionals and large arrays, the cost can start to blow up. And sometimes it's hidden where they are, as I said, because once it's highly abstracted, it becomes a bit harder to tell where that might be. Another thing to consider is just like, in general, if you have conditional statements and you can avoid performing inexpensive computation in that conditional statement, you should. Sometimes you can't, so you have to eat that cost. But if you can move it out of the if statement, you should do that. The compiler is going to attempt to do a lot of it, and so it succeeds like a good amount of the time, but sometimes it might not, because it is still like a pretty nascent compiler, especially with these more advanced optimizations. But that's something that I've seen developers also make a mistake for. But an easy way to like tell when you have these bottlenecks is to utilize a profiler tool that the Aztec team built. So Aztec built all of the protocol circuits for Aztec's rollup in Noir. So that is actually just like a normal classical Noir app. It's not a Noir smart contract. They are using Noir like as any other, Aztec rollup is just like as any other Noir app would exist. So in order to optimize those protocol circuits, though, we basically didn't really have much insight into what was going on because of Noir's high-level nature. So someone on the Aztec team basically built this profiler to analyze where the constraint costs coming from. So if you see like massive kind of blow-ups or just like unexpected costs, like we have tooling to hopefully help you kind of like, find those bottlenecks. And so that's also something that I think developers should also look at as well when they're trying to optimize their circuits.
Got it. Yeah, and it's really great that you guys now have a profiler to identify those bottlenecks. And as of right now, it's available for all devs to use?
Yeah, it's released with we have it's called Noir Up. It's a shell script similar to Rust Up and Foundry Up and all these other scripts. It'll just download the binaries that we release right now, which is going to be Nargo, the profiler. I believe those are the only ones we actually release right now, but yeah.
Got it. Nice. And in terms of just some other optimizations that Noir has taken, you mentioned previously that there are these black box functions, which consist of custom gates in the backend to try to, optimize for certain expensive computations. And then I'm also aware that recursion is also possible within Noir to help try to compress the proof size. So I'm wondering if you can speak a bit about some of the advantages that come with utilizing recursion, maybe which scenarios it's ideal to use recursion, which scenarios maybe it's not as necessary. Just curious to hear some more details about that.
Yeah, so recursion I find to be like most useful when you basically want to mimic unbounded computation in a snark. And by that I mean like when I have a ZK circuit, like everything is already pretty set, or it is set. Like you have a set trace that you have to send to the prover. You know, you're not going to be adding like new dynamic constraints all of a sudden. Like the prover needs to know what it's proving, and the verifier needs to know what it's verifying. But we can kind of mimic that. We can basically have unbounded computation using recursion. So now, I'm actually verifying a previous snark, verified a previous snark, and then I can kind of just keep doing that as much as I like need for my program. That's not as much of an optimization, but I think it's just like a very useful feature of recursion and a side benefit of being able to basically kind of actually have your program split up into a bunch of recursive snarks, is that now I don't need one massive kind of snark that I need to prove. So now, we've had functions in normal programming for a while, so it's kind of almost like we just have now these separate snarks, but you can like think of them as almost like different functions. And so basically, if I wanted to prove like a really big snark, it takes a lot of memory. Browser has a limited amount of memory. Maybe now I can like split up my program in a certain way where now I could do many different little proofs, and then I can recurse and basically verify. Then I just prove the recursive ones and then send that final thing to like the final verifier. So it lets you basically split up and chunk your program. You might not actually be optimizing. It actually might take a lot longer to do this because you're going to be verifying, you're going to be proving verification. So like snark verification. So that's pretty costly, and that's going to take extra time. So it might take longer to prove a program, but you might actually now be able to prove a program you couldn't have proven before at all. Like it would just not have been possible to prove in a browser, and now you can prove it because you've split it up basically. So that's the large kind of benefit we find with recursion. You can actually like really chunk your program up and kind of mimic this, basically a full function call stack that otherwise is not possible with a single snark circuit.
Got it. So it's really advantageous for those really big sized programs that are, really large in their proof size. Basically, you can split them up into almost smaller parts and then kind of verify them individually from there.
Sorry. Can you give it like an example program, like the one that, as you mentioned, would run in a browser that would benefit from this type of chunking?
Yeah, I mean, they're actually the ZK Passport team. I know for a fact for their circuits, they had to do this. They had to split up their program and essentially kind of connect their circuits using a recursive proof scheme because it was too big. It just did the requirements of especially when you want to be able to do it. Like I've been giving the example of a browser, but an even more constrained environment would be, let's say I just want to scan something on my phone, it'll crash if it goes over 1 gigabyte of RAM. So I really need to start to be considerate with how I actually set up, or like what kind of program I'm actually going to be trying to prove. I know for a fact that the ZK Passport team had to split up their program. And then also Aztec, we don't use kind of traditional recursion. We use folding underneath the hood. But Aztec's client-side proving is entirely like recursion-based due to this need, because we want to allow people to basically have arbitrarily large kind of call stacks. So you can I want to have a function that calls a function that calls a function, calls a function in a different contract, calls another function. And in order to do that, recursion is the best way.
Got it. And just on some of the topics relating to just some tooling that's available for these developers, you mentioned there's, the Nargo package manager. There's also some other tools that were recently released, like with the profiler. And, we were just talking about like browser-based applications as well. And I know that Noir also offers a package that helps developers build applications for the browser, the Noir.js package. So I was wondering if you could speak a little bit about some of the other kinds of resources that are available for, say, kind of developers who are just coming into the Noir ecosystem, or those who say want to do some more wide-scale client-side computation and may find the browser-based building browser-based applications most useful. So I was wondering if you could just share with us some of the resources, some of the tooling that that you think may be most helpful for these kinds of developers.
The thing that I think will be like the most beneficial to everybody who's just like programming Noir is we have a basically feature complete language server now. So this just means like when you go onto your VS Code and you download the Noir LSP, you now can program as you would expect, basically with any other IDE. For a normal programming language, you can click into functions, you can like hover, see browser definitions. We have auto importing. So if you have a massive library, you don't know what's going on. Oh, the LSP found this function in this library that you're trying to use. Maybe this is it. It's feature complete. So as you would expect as you're programming in any other IDE, you can do that in the Noir LSP as well. That's probably the most like just developer friendly, that just like greatly improves developer productivity and just enjoyment. So that helps a lot. And then of course, as you had mentioned, we have Nargo, which is our package manager, and we aim to be as as easy to use as something like Cargo is with Rust. But Nargo doesn't just do package managing, it also currently does this execution and witness generation. That might be split out in the future, but right now that's how it is. And so it does a little bit extra than just compilation and package management. And then we now have the profiler to let people start to optimize their circuits a bit more. Those are like the main true like kind of tools that you could use to just like get started and be like a really active developer. Once you want to actually start, maybe bringing the application to real life, you're going to have to start to work with the browser tooling. So we have a JS package that also lets you do, compilation, execution, all this stuff that you could do on the command line in the browser. You probably wouldn't compile in the browser, but you will be executing in the browser, and then you'll have to couple that with a backend that supports also some kind of browser-based or like execution. This is all once again assuming, we're still in the browser. Maybe there's a world where you're natively doing stuff on a phone, but that's a separate discussion. So that's probably the tooling that you would need to just like get started. I don't think you even need to worry really about anything other than Nargo in the LSP until you start to get, a little bit more involved. The profiler is only once you want to optimize. And then the JS, it's probably would be relevant actually before the profiler, because that's just when you want to like integrate your app into like something that people could actually use.
Got it. And just in terms of some other kinds of new developments, I know we previously talked about some of the proving backends that Noir currently supports, but I remember you also mentioned that there's a team, Pluto, who's also building a folding backend as well. So was wondering if you can talk about some of the new kinds of proving backends or new kinds of backends that Noir that are coming on Noir soon, and how you see increasing this kind of extensibility of the available backends affect the developer's experience.
Yeah, so backends actually were, even for a while, we didn't really have any other than Aztec's Brandenburg. Like as Noir has been backend agnostic since it existed, but the challenge with a backend is maintaining it and finding someone who actually like has the incentive and like the desire to maintain that backend. So we had people come along and build like maybe a Halo 2 like initial backend and a Groth 16 initial backend or something. But there wasn't anyone who's like, I need it, so I'm going to maintain it and I'm going to keep building it. And as Noir kind of got some excitement over the past year, teams that were looking for this combination of, oh, I do want to be able to prototype quickly, develop fast. I don't want to be handwriting my circuits, but like I need a DSL. I can't work with one of these zkVMs. I'm not willing to make an entire zkVM. They were like, oh, well, there's this compiler architecture that exists that I can plug into, and I'm gonna try that. Largely, this kind of same thought process with other like traditional compiler architecture like LLVM. So World is the ones that come to mind immediately that they wanted. They built like a new backend. I don't know actually if they built it or if they wanted to use this new backend and this new kind of commitment scheme that came with it. And they just forked Noir and started working on their own backend. And then Pluto also had slightly different needs and than Aztec does. So they did the same thing and they started working on Edge, right? Edge is the name. And so now we have kind of these two, backed, like largely well-funded companies that are actually themselves maintaining Noir backends, which is really exciting. And I think it's only going to lead to, more kind of upstream benefits back to Noir and like developers of Noir. Like it's just more, experienced eyes looking at the compiler, looking at this kind of, this code and, looking to improve it. And now they have a vested interest in Noir's development, Noir's continued success. So those are the two that come to mind. I'm definitely missing. There's like a few that have been integrated, otherwise integrated, but those are like the two like big ones that come to mind.
Got it. Mhm. And also wanted to hear some more of the nuances with, so you guys are first, like privacy first, or having privacy as kind of that default. But was wondering if you could tell us a bit more about some of the interactions between the Noir contracts and also the private state. So allowing the Noir contract to retrieve data from a private state store, how does that work, and how is that private state able to be maintained?
That's a good question. So like when going back earlier when I mentioned how like even though Noir has these like private inputs, it doesn't mean you've persisted anything. It doesn't mean you have state. So what we need to do is we need to how do we access that state in the middle of a ZK circuit? So Noir has this functionality that we call foreign calls, or oracles is another way that we refer to them. And an oracle is essentially saying it's like a syscall, but in Noir. We say we're leaving the Noir execution environment, and you can just feed me anything you want. Basically, here's a function name, and give me some data. And specific execution environments then can change what they feed based upon the given oracle that has been provided. So in Aztec's case, because it's probably the best example here. So we'll take, let's say we have an oracle that says, fetch notes for this person. So you have a node that's running in your browser that's going to see, oh, there's been an oracle call that's saying, oh, this user wants their notes, and then you'll just feed them back into the Noir program. And then after it receives that inputs from the oracle, it's going to keep continuing with execution. This is where also, once again, you need to be very careful because oracles, once again, you're leaving the circuit, and you're also leaving, if anything, just like the traditional Noir execution environment. So that's where Aztec really does come in. So that's how basically this syscall that we call an oracle is how Noir kind of leaves its entire execution, but it's then up to whoever is calling this, who's like which environment you're coding in to actually like provide for you like a persistent database that actually has this information. So like that, when you're calling an oracle, it's not going to do anything unless like you're working in an environment that actually supports it. Like in this case, Aztec, but it could be a different one. You could add your own kind of oracles, your own database that you want to resolve against. Does that make sense, or am I not being clear?
Yeah, that makes sense. Yeah, thank you. Oh yeah, Pablo,
Yeah.
were you going to?
Yeah. I guess very, very good relationship with like that external data fetching, and that the idea of being careful with what you're checking. I guess my question is somewhat related, maybe a little bit unrelated. So I know that there's other DSLs that exist, like Cairo and I guess Leo, and I guess like what makes Noir I guess stand out in terms of like other DSLs, like is I know it's a privacy focused, so I guess is there other things that developers would want to look out for and essentially use Noir for specific purposes?
Yeah, so just picking Cairo and Leo because they're the ones you mentioned, but specifically, Noir does not have the same value prop as Cairo. Cairo, it does not have privacy like as a default setting. You can add privacy by integrating Noir into Cairo, actually, though. So there's a nice value prop for Noir in that case. But with Leo, it's a little bit different because they are a zk DSL, but to my last time I looked at them, it's very specific to Elio's platform. And you have to basically be working on Elio's platform in order to be using Leo. Maybe someone from Elio can correct me after this if I'm wrong, but it's also it's not backend agnostic either, which I don't think I think it's very necessary to have that for like kind of the long-term maintainability of the language. There's new backends like every few months. You need to be able to kind of keep up with that, and the best way to do that is with an IR. And then, of course, Noir does try to really bridge this gap of developer experience, safety, performance, and I can't speak to how maybe other high-level languages like Leo have managed it, but in comparison to something like CIRCOM, Noir is significantly easier to write. It's much more just like programming. Versus CIRCOM's much more like programming like a chip, like a physical chip. You're not working with signals and gates. You're working with if statements and for loops. And then now, like Noir has, traits, closures. Eventually, we'll have more features, but we can maybe get to that in a follow-up. But then so we want to be as high level, but then let people really dive in if they need to. And we've seen some people write like very optimized circuits in Noir still, even though it is very high level. Yeah.
Got it. So there's quite a few advantages, like first, the DevX experience, and I know Noir is also very Rust inspired as well, like Cairo, but at the same time has that privacy as a default setting, and it's not just specific to the Aztec ecosystem, while at the same time being backend agnostic, and as you mentioned, kind of optimizing for DevX, for safety, for performance, optimizing for these features as well.
Mm-hmm. Yeah.
Mm-hmm. Got it. And wanted to also hear some more about some of the use cases that are currently being built using Noir, or maybe some use cases you would like to see being built in the future, ones that you find most exciting or most promising. Very curious to hear some of those that you personally are most excited about.
Yeah, actually, very recently, one of the DevRels at Aztec, like he built it as a side project uh, called Stealth Note. Basically, you can prove that you belong to a certain Google org. Like as part of your, like, if you have a Gmail, I can prove I belong to Aztec Labs, and you guys could prove you belong to House of zkVM, and now you can anonymous. So that's the only thing that's exposed, though. So it's almost like anonymous blind or Glassdoor, but truly private. Um, there's of course some caveats to that too, as well. I want to say, like if your administrator could see, maybe who signed in at a certain time. This where it kind of privacy isn't just the, oh, I proved it in a circuit, thus everything is good. There's other elements to it all the time, always, but that was just like a really recent thing that just happened, and I thought it was like really cool. Like basically anyone can, not necessarily snitch on their org, but they can talk about their org, or they can discuss things confidently without fearing kind of repercussions. But that's can be, I think, further expanded to how do we create these anonymity sets that are actually like meaningful. Maybe not just like a single crypto company, but maybe something a member of the government or something, somewhere that is like actually people have vested interest in hearing about perhaps corruption or other kinds of, bad things. So that's just like that's one specific recent case that occurred. But otherwise, the use cases I'm most excited for are just places where people are bringing like Web 2 to Web 3, I think is most exciting. Like how can we actually start to like connect these two, and like zk actually like is like giving us that ability. Like before, I don't know, people have always been talking about we're eventually going to bring everything on chain. We haven't really seen that, and I think it's largely privacy, but also like the experience of working on chain still isn't like very good. And now maybe, I could just like use my Face ID from my phone to sign into my wallet and then start doing some transactions. That is something you're going to be able to do with Noir and Aztec that you can't do right now, or at least in a convenient way on like your normal Solidity app. That's like a very basic example, but those kinds of projects are going to be like, I think, become very pervasive, and they're not just going to like expand use cases, they'll just expand like the user experience that we're like all now have grown accustomed to, but it's really not like a very good user experience in crypto. And so I see that as like really exciting, and I don't know exactly what kind of use cases people are going to bring, like once you can actually really achieve like Web 2 data in Web 3, but I think that's just going to be like the biggest unlock. That's going to be the next wave. There seems like there's always waves in innovation, and like that feels like the next thing to me.
Absolutely. And it's, really exciting that we're finally at that point where we've, in ZK development, where we can apply some use cases, even beyond Web3 into the Web2 space, and having that ZK as a kind of a bridge in between those two spheres. So really, really exciting time that we're currently in right now. And just as a
Absolutely.
last question before we, and just as a last question before we close here, I'm wondering if you can discuss about what maybe developers can expect next in the Noir roadmap following. I know you guys had a pre-release late last year, and also how Noir ties into the overall like Aztec, what role Noir has in the overall Aztec ecosystem and vision, and some next steps that developers can take.
Yeah. So as you mentioned, we pre-released our 1.0 like release. That basically just means we're on our way towards stability. We've had a lot of, especially for people who are building upon Noir or are just or just developers on Noir. There's going to be breaking changes, and next thing you know, you have to completely change your circuit because, maybe we just realized we did something wrong, wanted to change it. We're trying to hit a place where, all right, this is stable. Your circuit, if it looks like this, it's not going to change. Or like you're still going to be able to compile it and still work with it. So what you can expect in like the most near term is efforts towards stability, and like with 1.0, you're not really going to see necessarily now like new features. You're going to just see like we're trying to finalize those last bugs that we think are critical, get a minimal viable kind of product that we can give to auditors to start to actually like look at the safety of our compiler. So that's probably the most immediate term, is really just like stability testing, and making it like not a unstable environment for not to say stable again, but for developers. And then in the future though, post 1.0 is when it kind of opens up again for like us as a team to be able to start like working on new features again. The most exciting feature is probably like enums, match expressions is something that most developers are going to want. Noir doesn't have that currently. So that's like a very large feature. Otherwise, it's going to be then other kind of large changes we can make to the compiler to make it easier also for other developers to integrate. So even though we're backend agnostic, there's certain challenges right now that prevent us from being 100% backend agnostic. I don't know what percent I could say we're at now, but there's some assumptions we make in the compiler about field size and how we handle certain fields that you couldn't easily compile Noir to every single proof system that exists out there. So certain just internal compiler changes that are decently pervasive but require a good amount of effort. That's something that's going to be happening post 1.0. And that's because, so you shouldn't expect like large feature changes in the near term, but in the post that's when you're going to start seeing a lot of new development again.
Yeah, awesome. So very busy time for the team, and also just a lot of new developments coming up in the future for all the end users and the developers in the audience. So yeah, that's great to hear. And thank you so much, Maxim, for joining us. Really enjoyed hearing about all the details about Noir, especially how much focus you guys put on giving developers that choice, the amount of customizability options that you have, especially with like the proving backends, and giving developers the opportunity to navigate in that trade-off plane between safety and optimization, and then also how you guys treat private inputs as the first-class citizen. So really enjoyed hearing all of the value props behind Noir, and also some of the use cases that are being built on it as well. So thank you so much, Maxim.
Yeah, of course. Thank you. Thank you for having me.
Yeah, thank you.